We are trying to talk about the reaction force on a car that is going through a bend with a certain curvature, and in such bends, what happen is there is an angle theta here. So the road is not just horizontal; it is bit curved. As a result, it has an angle with the horizontal, which is theta. It's usually a small angle, so that the friction can stop the car from sliding away. So anyway, with such problems, what we have to often we have to find the reaction forces, or what is the maximum velocity with which the car can go and such. So if we think of the reaction force, that will be in this direction, horizontal to the path. And of course, if the path was horizontal, then the reaction force would be very simple. It would be equal to the weight of the car, so that would be R is equal to mg. But in this case, that won't be the case because this is inclined. So we can think of two components of this. This is R, so there will be this horizontal, and there will be this vertical component we can think of, which is uh, compensating the weight. Of course, the R, this will be equal to the weight mg, and this horizontal one will be equal to, since the car is going in a circular path, as if in that portion at least. So if the circular path's radius is R, there will be a centripetal force, and that centripetal force will be equal to this horizontal R component. So if we say R vertical, that will be mg, and R horizontal will be mv square over R, because that is the centripetal force. So that's fine. Now let's write these two in terms of R. We can see that this angle will be theta, because this is theta, and this angle is 90 degree. So as a result, what's happening is this angle here, the one that I am drawing, is 90 degree minus, 90 degree minus theta. So as a result, the horizontal component will be R sine theta, and the vertical component will be, because this is actually theta now, this angle is theta, so mg, this will be R cosine theta, and this one will be R sine theta. So we can write R sine theta to be mv square over R, and R cosine theta to be mg, equal to that. So often in this kind of problems, we need to find what's the maximum velocity of the with which the car can go through the bend. Usually in such problem, those kind of problems, the radius of the curvature is given, the angle theta is given, so all we need to find is v. So we can do that without finding the reaction force. So let's call this equation 1 and this equation 2. So what we can do, we can find an equation by dividing 1 by 2. That will give us R sine theta here and R cos theta here, equals to mv square over R mg. So that will be, R will get cancelled, and tan theta will become, m will get cancelled, so it will become v square over rg. So here we have an equation which allows us to find v square, v basically, when r is given and theta is given, or if v and r is given, we can find theta and so on. So we can do that without finding the reaction force. However, if we want to find the reaction force, what we can do, the expression for the reaction force, we can do 1 square plus 2 square. So that would be r square sine square theta plus r square cosine square theta, and that will be here mv square over r, this one square. So I'm not doing that, I'm just writing like that. So this will, of course, sine square theta plus cos square theta is 1, so r, and the bracket term will become 1, so that will be there, and r square here, so it's the same, so r will become like that. So That way we can find R as well if we are asked to. So yeah, I just thought of doing this small video.